And welcome back with some more on how things work. I've listed here all the basic numerical data types, starting with the theoretical most precise or the largest possible one being a long double, followed by a double, followed by a float, an unsigned long, a long, an unsigned int, an int, and then down here at the bottom is kind of sort of what's left over. Here's what happens inside C++. Last lecture I talked about implicit conversion or implicit coercion it's also called. You'll find that online. What happens is if you have mathematical equations going on and one of the numbers is of a type considered more precise, everybody else in the equation gets up converted to match it. So if you've got floats, unsigned longs, and everybody down here to the bottom, all the way to ints, gets converted to a float. So funnily enough, characters, shorts, and unsigned ints, or unsigned variable types, these guys all down here are automatically converted to type integers. The caveat to all this is this all depends upon the size of the value and the size of the system value. So if an integer contains 4 billion plus or minus, because that's the way it's working on your system, and you've got an unsigned something or other int, and the number that it's working with is big enough to put it in the int category, it's just kind of automatically there. The system automatically takes care of it. So what we've got going on is basically implicit conversion up to the top of the list. These will happen automatically. So you don't have to worry about that. It's just kind of the way it's going to work. Called implicit conversion. However, let's say, for example, we've got something like this. We have pizzas, because everybody loves pizza. We also have a constant. So this is the number of slices per pizza, which makes reasonable sense. We have people. So we're going to try to figure out how many slices each person needs. And then figure out how many pizzas we're going to get. So we have to ask a couple of questions. We have to ask them, how many slices is someone going to eat? And how many people are coming to the party? We need to ask. And then we need to grab it. Now, some people may have thought about this for a second and said, people, pizzas, and slices, all this kind of makes sense in terms of what we're doing, but it doesn't always make perfect sense in terms of mathematics. We can't have half a person. Well, not really. Just have half a person shows up, that's messy. People don't normally eat 1.5 slices of pizzas, and you can't order a partial pizza, at least not where I am. You have to order whole pizzas. Unless, of course, you're ordering those ones with pineapple and ham on them, and you can order 0 of those. We don't need to do the math on that. So if we wanted to find out how many slices total we have, the answer to that equation is going to be the number of people you have times the slices per person. And that'll give you how many total slices you need. And if you recall, we actually need to figure out how many pizzas that works into by dividing it by slices. And if you recall from last time, that's kind of the math. Now, mathematical order of operations says we'll work left to right, multiplication, then division. But I would argue that for readability and for your illumination, you probably should do something like this. That way you know that it's people times slices, and you get a whole number, and then you divide it by the total slices to get the actual answer of how many pizzas you need. So this will give us roughly the output that we want. So let's put it in. And as last time, we'll clean it up a little bit. For the number of people you gave, you'll need this many pizzas based upon the number of slices per person. We can leave that out. So let's run it and see what happens. We failed. Oh, we forgot that dreaded semicolon. There we go. So the number of people here, we're going to say there are 8 people. And they each eat 1 slice. And for 8 people, we need 1 pizzas. Which, that works. If we have 8 people, and they each eat 2 slices, we need 2 pizzas. Which, again, whole number seems to be working all right. We have 7 people. They each eat 2 slices. For 7 people, we need 1 pizza. What? 7 times 2 should be 14. 14 is a whole lot more than 8. Therefore, we know mathematically that this is not quite correct. This is not working in our favor, per se. So what this is showing you is the integer mathematics, the division that's going on, is giving us only the truncated part of the math. So 14 divided by 8 is 1 point something. The point something is what all goes away. So we have to find a way to fix this. Now, there are a bunch of interesting ways of doing this. We can do a couple of things. We can come back here and say, well, just for giggles, let's turn that into a double. Maybe this will solve the problem. 7, 2, nope, we still get 1. What's going on here? Well, all of this math, every number that's in here, every number that the math is working on are all type integers. They're staying the same. And we want to actually convert these guys to something better. An implicit conversion is not working. Are there multiple ways of fixing this problem? Yes. But what I wanted to show you was this. We have the ability of up-converting things by hand. We can force it using something called static cast. The static cast is a type thing that says, take what comes next, and turn it into one of these things. This is a static cast, happens statically, doesn't happen at runtime. It says take what's inside the parentheses and convert this to a double. Now, the side effect of this should be this becomes a double because we told it. Slices says, hey, if you're a double, I need to be a double too, and it converts itself to a double. And then we're storing it in pizza, which we've converted to a double. So we will actually get the actual math on the number of pizzas. So this gives us what's going on inside of the mathematics for it. We can force it, see both an explicit conversion and an implicit conversion to get an explicit answer. This is one way of solving the problem. Now the question stands is how could I get this to be an actual number of pizzas that I can order? I can't order 1 3/4 pizzas. Well, something that exists out there, it's actually part, I believe it's a part of the math library, but we'll find out here in a second. We have a command called ceiling. Ceiling says take this number and give me the rounded up value of it. And there you go. Ceiling gives you the rounded up value. The counterpart to ceiling, by the way, is a command called floor. And once again, these are things you got to start digging through the libraries and finding out. Some books mention them, some books don't. But ceiling, round up, floor, round down. Note that I didn't store it anywhere, so this is a temporary value. This static cast is a temporary value. It happens only at runtime and does not change how anybody up here is stored. It only changes the result of the mathematics. If I was to do this correctly, I would actually take the static cast double and I would force everybody to be statically cast because I said so and not trust anybody's implicit conversion. So in today's lecture, or this little piece of lecture, you saw a little bit more about how mathematics works, how casting implicitly and explicitly works, and you saw a new little feature called ceiling, which gives you rounded up values, and then the corresponding thing is floor, which gives you rounded down values. So, hope you're having a great day. Talk to you later.